Maybe not. Okay, so what's up, Pi Gamers? Welcome to the day 8 of this Pi Game Camp. And today we're gonna be ending our first project, the Balls of Ball Game. And I just want to show you what we did till today. This is what we did till today. And here's all the stuff. Now we just did the check stuff, the check for all of the check function, which checks if the ball is not leaving the game boundaries. And what's like we have defined the classes for both the balls. We have included all the libraries. We're gonna use this math library also for the collision. That's the main point we're gonna discuss today. And we have declared all the lists for all the balls, and we're gonna like there are all the for loops right here, and there is the main game loop, which has nothing instead of just these three things. So just spare me for a moment. I'm just bringing the code in just a second, and I'll be back in less than some time. Just a second, I'm just coming. Okay, guys, so I'm here and I got the code with myself just as we do make any kind of errors. And what we're gonna decide today is the collision, and we're gonna put all the small balls onto our game window. So let's see what our game looks right now. And then, okay, so our game is nothing like we have defined the user ball. We have given the text function above. We can just use the arrow keys to control the ball just like so. And we have the small balls that are left. So that is what code we're gonna write today, including the collision. Like if the player's ball is gonna touch the small balls, then we have to erase the small balls, and we have to make the radius of the user ball a little bit bigger, because as we decided when we started the game, each time the user ball is gonna collide, or let's say eat a ball, its initial radius increases. So how can we like get the small balls out of the window is that we have made some lists right here for each of the balls of every color, and we got like this is the main function. So in this loop that we wrote in the last session, we just put all the balls, the visual balls. We have not put them onto the window. We just put all these balls into that list, but we're not able to see them. So how can we see them? We will be able to see them. First, let me just show you how we can just process the collision thing. So here, this is the code for the collision thing, and I'm gonna show you a link real quick. I'm just gonna open Google Chrome just like so. So once Google Chrome is open, I'll just paste the link, and there you go. This is a formula just right here. As you can see, the distance between two midpoints and the midpoint. So that means the user ball and the small balls that the user is going to collect. The distance between the radius, the radii of these two balls, that will be calculated by this particular function, which includes the square root of all the radii. I'll just explain them to you in a minute. And before that, uh, we can learn a little bit about the math module in Python, and that's all about the functions of math module. So here inside this, we're gonna start our second projects today. So first, I just go to, okay, that's for the second project. I can just make a new Python file and name it as P, just for practice. Now first, I'm gonna import the math module. So this is a in the module in Python. You don't need to install it or anything like that. And then here are the functions that we can learn from the math module. So the first function is math.ceil. What it does, it rounds up the integer to the float number, we can say, to its nearest integer. So first of all, let's try this out. So first we give a print statement. Inside of that, we can write math.ceil, and inside of this, we can give the integer, for example, 123.123. And if I run this, it will show me 124. So this is the nearest, let's say the number which this math module is rounding up to. So for example, if I give it as 99.1, let's see what it rounds it up to. So it runs it up to 100, and this is basically how that function works. And yeah, the next function we're gonna decide is, like, we're gonna use is the fabs function. This is nothing but it just returns the absolute value of the float number inside of it. So absolute value is nothing but okay. So for example, we go print. You must have learned this in school. It's just programming here. Add.fabs, inside of this, I can give any kind of float number. I run this, and here we get the absolute value. And okay, we're gonna learn the functions real quick because I'm not gonna waste time in learning the functions in detail. You must have learned about factorial of a number. Now, what is factorial is a given number. For example, let's say 5. The factorial of 5 is 5 into 4 into 3 into 2 into 1 till the number is 1. So that's basically the factorial. Now here we can just say, sorry, print. We can give the print inside of this match dot factorial, and I can give, let's say, 10. Let's find what is the factorial of 10. Don't use this to cheat in your exams. Okay, the factorial of 10 is whatever. Here, factorial of 5 is 120. That is 5 into 4 into 3 into 2 into 1. The next step is math.fmode. Now what this function does is it divides the first number by the second numbers and gives the remainder. For example, if we take print again math.fmode, I say 100 and I say 11. So 11 nines are 99. So the remainder is 1, and that is what its output should be. Now here it is giving me in the form of float. If I want to convert it into integer, as we all know, we have learned in Python that int is the function to convert float into integer, and we get 1 when we run this. The next function that we're going to talk about real quick is the math.fsum. Now there are many types of data types like lists, tuples, and arrays. Lists and arrays are kind of same in Python, but still. For example, we have a list. What is a list? A list is this something like this equals to, and we can put any value inside of square brackets, even strings. But as this function says, that is the fsum, we have to what this function does is basically it takes an iterable, that is a data type which has many elements, and it sums all of them and it gives out the output just like so. For example, I take print math.fsum just like so. I give a list inside of it and I say 10 comma 1 comma 20 comma 2. So what the answer should be is 11 plus 22, that is 33, and hopefully we get that but in float form. And if you want to convert it to integer again, use the int function and it will be converted into integer form. Now instead of this list here, I can give a tuple. Now what a tuple is the same thing as the list, but it's inside brackets or parentheses, and it has some different properties other than list. So it will give the same output because it is used to calculate the sum of iterables. Next is the math.gcd. You must have learned in school the HCF, the LCM, or the GCD. The GCD is the greatest common divisor, and HCF is the highest common factor. They both mean the same. So inside of this GCD function, we have to give two values, and the function, the method, or let's say the method will calculate the GCD of these two numbers. Okay, so for example, I give print math.gcd, and here we go. If I give it as 35 and 7, we know the GCD is 7. Let's see if it works out. Yes. And this time, just notice it gives me the output in the integer form. And even if I enter like something like this, now it is efficient to calculate the GCD as 1. I think these are some, I don't know, the GCD is 1. That is what the math module is telling me. Now math.square root. Now this is the function that we will use in calculating the collision. As you can see, we have a square root, so that is the function that will help us in calculating the square root. Okay, so for example, 49 is the square of 7. So for example, we say math dot square root, and we can say 121. Now 121 is the square of 11, and that is the output. Again, if you are to convert this into integer, you can just use the int function. For example, I give it as 36. We all know that 6 is the, like 36 is the square of 6. So here we get 6, but in float form, doesn't really matter. And yeah, that's all we're gonna talk about. Now let's see. Now, if you want to be a efficient programmer, what you have to do is you have to get information from all around the world for the project you're basically developing, and that is how basically you get this information right here. That is the radii of the first thing and the second thing, and you require 4 values, and you square all of them, and then you square root all of them, and basically that is how it works. So let's get back to our code, just like here. Now we're gonna define it as collision. So let's say we define this as def is collision. I'll just name it as is collision. I'm gonna take 4 values. So first is the small x, that is the x coordinate of the small ball. Next is the small y, that is the y coordinate of the small ball. Next is the, okay, so next is the ball x, that is the, now we can just arrange this in like ball x so that we can just put in the values real quick, and ball y and small x and small y. SM is the just the short form that I'm using for the same. Now, as we discussed about while developing the class of the user's ball and the ball, we define two functions like show x and show y that are gonna return the x and y positions of the balls respectively, and that is the same case in the big ball, the show x and the show y function, and that is basically we're using. So first of all, we just define the distance between the two things in a variable, and that is how we define it as math dot sqrt, that is square root, and make sure you import math at the top of your code. If you don't import math, then this won't work. So after you have imported math successfully, math dot square root. Now instead of this, there is a function of math dot pow. So what this function is, let me tell you, print math dot pow. Now here it requires 2 values, that is we can give it anything in integer form. Now the first value is 2, that is the base, and the second value is 2, that is the power. So the output that we should get is 2 raised to 2, that is 4. Here we get it, 4. So this power function, or in short power function, can be used to calculate the power of anything. Now here, as we can see, we have the power of the difference of these two to 2, and we have got the same here. So there is where we can use the power function. So let's go back to our code. Math dot square root. Instead of square root, we can give math dot pow. Inside of this, we can just give the ball x minus the smx. So the ball x, that is the x coordinate of the ball, minus the smx, and comma, we have to raise it to 2. As we can see in this formula, we're just going according to the formula that we're including nothing external or something like that. So we have got the difference of these two, and we've raised it to the second power, that is the square of whatever the difference is. And after this, we can give a comma, because is inside the math dot square root function, and we can give it as something like math dot pow. Inside of this, we can just give ball y, that is the y of the big ball, minus the smx, that is smy, that is the y coordinate of the small ball, divided by 2. And here we go, I think. Okay, okay, so there is a plus between this. There is not a comma but a plus between these two, because as you can see, these two um, terms, or let's say equations, we can't say equation, we can just say terms, are added inside of the square root. So after we successfully just added the powers and square rooted them, whatever, and if the distance is smaller than 27 pixels, that means the radius or the circumference of both the balls are touching, and that's when we want to remove the ball from the list. So right now we don't define it to remove the ball from the list in this function, because we don't need it in this function. We can use this if distance smaller than 27, and 27 is the value that I'm using. If you're making bigger balls in a bigger window, you can just use the trial and error method, put in different values, check if that's working. So if the difference is lesser, or whatever the equation is lesser than 27 pixels, we have to return true, else we have to return false. Return false. Okay, so we have successfully made the collision function. And after that, now let me show you how the main thing would work. So there are two kind of stages in the window. First, when the game is running, and second, when the game is over, when there are no balls left. So how do we define when the game is over? Is that basically when all the lists are empty, that means the lists are empty. That means all of these lists are empty. That means the game is over. It's simply over. And that's how we define it. Now we'll need two variables to run this. The one is h equal to true. You can name it anything. I'm naming it h, and I'm naming it g. So h is true. So while h is true, we're gonna run the game. And if g becomes true, we're gonna end the game. So that's basically that's how it works. Okay, so h is true and g is false. Now let's say while, okay, this is the show function that just basically shows whatever is going on. Now let's say while h is true, we're running the game, right? So we can put all of this code inside while h is true. So here we say while h equal to true, we can just control and indent this. So while h is true, all of this will happen. So we're gonna fill the screen with white. Okay, so we can just define it as screen dot fill white. I think we've defined it like above. Have we? Let me just see. Screen and set icon. Okay, no. So we haven't defined it to be white, but still inside the main game loop, we'll just say screen dot fill white. Okay, we can just enter it. Let's see the show function. Okay, we haven't defined it here also. So we can just say screen dot fill white. At any times, at any point of time, it will be white. Okay, we have defined it here, so we don't need to do anything above, but we can just erase one of them. Now, how can we display them? Now, there's a really simple method to display them. Here, let me just create some space. Now, right now, all of these lists are filled with balls because we've added the code right here to fill the virtual balls. We can't see them right now, but we want to show it on the window. So basically what we will do is we will iterate through the list. So for ball in red balls, here we go. For ball in red balls, so let's take red balls for example. We can say ball dot draw it. So we can say the ball should draw itself. Like, so for every ball in the red balls list, the ball has to draw itself on the window, just like there. Next, we have to define the collision. If there is collision between the my ball, so what is my ball? My ball is the user's ball that we have defined it here as a big ball class, the instance of a big ball class. So my ball dot show x. So here is where these functions come to use, comma my ball dot show y. We can say my ball dot show y, and then we can say the ball that is for ball in balls. We can say ball dot show x and the ball dot show y, just like here. Okay, so we've successfully completed. Just let me give a colon at the end because that's the syntax. Now, if there is a collision between any of these two objects, that is the user's ball and the balls on the screen, what do we have to do is we have to remove the ball from the balls list. So it will simply disappear, right? Because if it's not there in the list, then it will disappear from the window because they are blitting it while the game is true. So ball dot remove ball, and then what we have to do is we have to increase the my ball radius by 0.1. You can choose any value, but I'm doing it for 0.1 just so you can literally choose any value. So if there's a collision, then this ball is out of the screen and there is a change in the radius of the user's ball. Let's see how that looks. So right now we can see all of the red balls gridded on the screen. Let's see what if we touch a red ball. So there is an error. Unsupported type this for big ball and float. Okay. So maybe there's a small glitch here. Maybe we didn't convert it into some integer values for, let's see here, distance equals to math dot square root math dot pi. um, Seems fine. Let me just see what the error is. If there's a collision just like so, unsupported, okay, my ball plus, oh sorry, here we have to increase the initial radius. I just said my ball plus equal to 1. What is my ball plus equal to 1? So my ball dot any radius, that is the radius of my ball, is plus equal to minus 0.1, whatever. Now if I just run this, you can see the balls are disappearing from the screen just as we touch them. See how beautifully that works. And the radius is also increasing. Sorry for that. Now that's basically how it works. Now this works for the red ball. Now we can just copy this code just like so. Copy it and paste it for 6 times because we have 6 colors right here. Just like so. just like so, just like so. How many times? One, two, three, four, five, six. Okay. Now instead of red balls, let's just see what colors we have: green, orange, pink, blue, and gray. So green balls. Oh, not gray. Green. Green balls. There's a list named green balls, right? Oh, I just named it as grand balls. What is grand balls? Okay, so it will have some things here. Okay, I've just changed the spelling for that. Okay, green balls. And I think we have some blue balls. Okay, we have blue balls. Now I just wanna change here. We have to remove it from the green balls list, not from the red balls list. So here inside of blue balls, so what I'm doing is basically I'm just doing the same thing as we did for the red balls for all the lists. So here we have the gray balls, and here we have the red balls, let's say the gray balls, just like so. Here instead of red balls we have orange balls. We had orange balls. Here we go, orange balls, not remove ball. And at last we had the pink balls. Okay, so hopefully all balls will be visible on the screen. Pink balls. And boom, we have, wow. You see how awesome. This game is kind of really awesome. Just develop it and you'll enjoy it. Just develop it. Now, the only thing left is the game over. So when there are no balls on the screen, we have to declare it as game over. The game is over. Everything is over. You have won the game. You have collected all of the balls. Thank you for playing. Something like that. The end screen, we can say. Now, here is where these things come into place. That is the variables, the H and G. That is true and false. Now, while H was true, we saw all of this function. Now, how can we make G true? If all the balls are the list, if all the lists are empty, that means that there is no ball on the screen, and we have to change the screen to some another kind of screen. So here, under all of these functions, let me decide it. For example, not for example, if the length of red balls equal to 0, or oh sorry, and length of green balls equal to 0, equal to 0, and the length of gray balls equal to 0, and the length of orange balls is equal to 0, and the length of blue balls is equal to 0. So how many colors are there? Red, green, gray, orange, blue, and there's pink. And the length of pink balls is equal to 0. That means there is no ball on the screen, and we can say that we have to change H equal to false. That means we don't have to show the starting screen, we have to show the ending screen, and we can make go equal to true. And while go is equal to true, what we want is we want to show an end screen. Now how do we do that? Instead of this whole thing was the while loop while H was true. That is while the game was running. Now the game has ended and there is no ball on the screen. Now what will the user see? So before we see what the user will see, we can just say while go equal to true. That means the game is over. While go equal to true. Oh, there is no go. There is a G. Sorry. Go equal to true. Just say G equal to true. So we can make G equal to true. Now while G equal to true, we can just define like Now this loop that is for event in pygame dot event dot get, for event in pygame dot event dot get, if event dot type, that is if the user quits anytime, we have to write this loop for each and every time while the game is running. For pygame dot quit, we can say pygame dot quit and quit. Now after this is done, what we can say is we can say change the game. Before this, we can just pygame.display.update. Now after this, we can say here we can say as change. Oh, we haven't defined the change function. Okay, no problem. We'll just define the change function. So what the change function will do is it will just change the screen. Now how that will work is here. What have I done? Okay, def, we can just say change. Now this will take the screen value inside of it and the color in which we want to change it. Now this will be useful for the next game that we're gonna build, and therefore we can just see how this will work. So first we will say screen dot fill with the color that we have here. Now screen dot fill color. Once we just say screen dot fill color, we can say a equal to, we're just drawing some text of game over when there is no ball on the screen. So basically the text will look like this: pygame dot font dot font. Here we go, ob dot ttf, that is Orbitron font, and we can say the font value to be 50. Now L equal to a dot render, and the text that we want to show is game over, like so. We can say the visibility to be true, we want it to be seen, and the color of the text is 255, 255, and 120. Now this is kind of a lime yellow color. You can get any color of your choice from the internet, it's open. Now screen, okay. Now here, instead of capital S, we can give small s. Screen and screen dot blit. What we have to blit is basically L, and the coordinates at which I want to blit it is 300, 400. My window size is 900, 900. Now inside of this, we can say change the screen. You can give the screen, and I want to change it to the black color. Oh, sorry. Defined it as, sorry, black. After we have defined it as black, we can say we're gonna change the screen and we're gonna update the game. Okay, so we're gonna, just a second, we're gonna update the game before, okay, after. So pygame dot display dot update. Okay, let's run the game. So right now I don't have the time to collect all of these balls. I'll just decrease the value of these balls to just to show you the game over screen. So instead of range 30, I'll just give range 1, 1, 1. I just want one ball of each color so I can collect it, and we can change the screen. Okay, now I'll run this. We got one ball of each color. Okay, why is this thing? Okay, come on, collect all the balls. Oh, this is, oh, boom, I just missed it. Ah, yes, I got one. Come on, get all the balls. I got two. I got, oh, yes. Yeah, 3, 4, 5. What a streak, huh? Oh, okay, here's the window. Trying to collect the last one. Oh, I missed it. Ha ha ha, yes, yes. Yeah, oh. Oh, come on. I want to show you. Okay, so once there are no balls on the screen, we can see a game over screen just like so, and we can just cancel it anytime, and boom, our game is over. So congratulations, you've completed your first project on this game. Now, the second project that we're gonna build is the maths quiz. Maybe take a small break before we continue or the second project. Okay, so I'm gonna open Google Chrome. I'm gonna go to Google. Okay, so it's working. Let's make sure that the internet's working. Okay, now this is the code for the second game. Don't worry, I'll be teaching it step by step. Now, what the game will look like is something like this. Just end it and restart it. Boom. Okay, so there is some text inside of this. There's a button to start the quiz, and then we can just press the key. Now it will show you as correct or wrong answer. For example, I press the key 1 and it's a correct answer. I press the key 3, it's a correct answer. These are some questions. I'm just going through all the questions. And the last question, not the last, this is the last question. So wrong answer and correct answer looks like this. At the end of the game, you can see your score. So that is the new thing for all of you, because that will be useful in the last project that we're gonna build after this project, and that will be kind of complex. So make sure you get all of these concepts really, really well. So before I jump into this, so this is the thing that we build. Now just let me change it to 30 so that there are 30 balls of each color. Boom. So that was your first game, and you can just close it. Okay, let's just close it from here. Okay. And now I'm gonna just get a new Python file. Well, sometimes it just appears like that. Okay. A new Python file. We can say it quiz, and we'll create it. Now, there, as you can see in this, as we run the game, first we get some text that we've already learned. The button is a new thing. Next, we've got some images, and we've learned how to get the keyboard arguments, all of the stuff like the keyboard inputs, basically. So basically, there's a red text for a wrong answer, and there's a yellow text for a gray answer, and after that you get a score, and basically that is the quiz game. So what I want you to do is, before you start coding this, just get all of your questions into one place and make sure you keep them organized. If you want, I'm gonna make a quiz of 9 questions. If you want, you can add it to 20 or even 100 questions. That doesn't really matter. And you can just make a simple quiz game as long as 3 questions. So the libraries that we're going to use in making this game are, of course, the pick button library. That is a new library. I'm going to teach you. There's a time library. It's really, really simple. There is a pygame library, and we don't need this code, so we can just demolish it. Okay, so these are the 3 libraries we're gonna use to create the next game. So here we go. We can import the pygame library really quick. Importing the pick button library. Now how can you now this is not a built-in library. If you're using this IDE, that is PyCharm, what you have to do is you have to press Ctrl Alt S. It will show you a window like this. You can just say interpreter. You can click the plus sign and you can just enter pig button, pig button. That's already installed, so it is really not showing me because that's already installed. As you can see, there's a pig button and a pym library. So these are the 2 libraries that I have installed in this project. If you're creating a new project folder, then you have to install it in that one as well. Now, time is an inbuilt library. You don't need to install it. Starting with our next game, the maths quiz. So basically, today we're gonna be covering the button working. So I just want to show you how the button works. Now, before that, what you can do is from any of your previous games, you can just copy the starting codes because they're really the same. So you can just copy this and paste it here. Here, this is the initialization function that you need all the times. Here are the colors. Here is the width and length. In this game, I'm gonna keep it 900 and 900 as well. Now these are some images. I don't need to set the icon. If you want, you can set the icon. Now the caption should be maths quiz. Now not maths quiz, you can choose like any subject you want. I'm choosing maths quiz, just like so. Now here in this folder, I have this image, this image. This is Python library. Python. Okay, I can just show you some images. These were the images we used to learn. This is an image, and this is not useful. This is an image that we're gonna use, and this was for the previous game. So basically, I'm just gonna go to quiz.py. Here, I'm gonna load all of the images just like so. I'm gonna name them as cube. It is the cube photo igame dot image dot load. Inside of this image dot load function, we can just give the name that is cube99.png. I renamed it as cube99. Next is the tank it. This is the variable that holds the igame dot image dot load. Now the name for this image is tank.png. Next is the chess equals to pygame dot image dot load chess 1.png. Now this chess image is a little bit bigger than what we need, so we're gonna transform it. We've learned transforming the size of the images in the images session previously. If you haven't seen, go there and see the video. Come back real quick. Okay, so pygame.transform.scale is the function that is basically used to resize the image to 400 and 400 pixels here. I'm going to resize that to 400. Now the colors are already defined. Caption is done. And boom. Pygame dot display dot update. Before we go into the loop, we can just update everything outside of the loop. Now I'm going to talk about the pick button library a little bit. Now this is just a small library with some little functions to create a button on your screen. So basically, let's say run equal to true, not run, we can say running equal to true. You can name it anything because they're just variables. Now I just don't want to write the code again and again. What I can do is I can go to the main.py here, no bookmarking. Inside the main game loop here, I can just copy this particular code, this piece of code. I can just copy it, go to the quiz.py, I can just paste this. So that makes our lives a little bit easier. Now here I'm gonna create a button equal to here the function for creating a button is pick button dot pick button. This is the function. I don't know why it has pick button dot pick button, but this function. Now inside of this, you gotta give another set of brackets, another set of parentheses. We got 325 comma 600 comma 270. So the first two values are the x and y coordinates where the button will be seen. and the next two values are the width and the height of the button. After this, we can just give a comma, give a string, and say start the quiz. This is what will be appeared on the button. Now start the quiz, and yeah, that's basically it. So it becomes really easy to show the button on the screen. Now here, if I just want to blend the button on the screen, what I can do is a simple function that is named um okay, button object dot draw. Okay, we have some time left. Okay, so here I can just give button dot draw. That is the function that draws that button onto the screen. You can just give it as screen, right? Yes. So this is the surface where it will be drawn. If I run this real quick, you can see a button on the screen. Now nothing happens if you click this button. I'll just tell you how you can program this button. Okay, so now inside of this event.get, I can just make another if statement. If inside of a string, I can give click. If click in pygame, sorry, not pygame. If click in button dot handle event, and inside this we can just give event. Then we can say sha equal to true. Okay, sha not equal to sha equal to true. I'll just make you understand what really happened now. Now this is a string that now as I told you, what happens when we just loop through all the events in pygame.event.get. What really happens is there's a list of events, and inside of that events there are different type of events. Like there was a click, there was a drag, there was a hover over this element. There are all the data is basically stored in that list, and inside of that list, if there is a click event in the button.handle event. Now handle event is the name of the function. It's nothing complicated. It's just handle event, and inside the brackets we can say event is the same thing as here for event in package.event. Now cha equal to true. Now cha is a variable and it is true, as simple as that. Now what if cha equal to true? If we can just say if. Now before that I can just define a function that is draw text on the function. So hopefully we've drawn it in the previous game also. So here, let me just go through the code. Okay, this is the code. Now here, there's a draw text function. I can just copy this function. Basically, it just shows some text onto that system clipboard is unavailable. Why is it unavailable? I can just ignore that warning for now. What if I just paste it here? Okay, so there's a draw text function. Am I really audible or am I just speaking myself? The internet's there, right? Okay, I'm connected to it. No worries. Now, this is basically a function that draws any kind of text. We just learned it in the previous session that just draws some text onto the window. Now, what if cha equals to true? Let's get back to it. If cha equals to true at any time. Now basically we can just define cha as false, cha equal to false, so that it doesn't give me any error even if there's some kind of a glitch. Now what I can say is I can just say to draw some text. Now we can say the text. What is the text? I can say test. Okay, I'm just gonna say test because I'm just testing it to work. Now the size, that is the font size, let me give it as 30. I don't know how it looks like. I can just give 100, and the color is to be white. Should be white. Let it be blue so that at least it's visible. Not black, man. What? Blue. Now what happens when we just run this? Now there's a button. If I click on this button, there's a text. So Did you just see how quickly that happened? Okay, so click. Okay, once that is visible, that's visible. Okay, now if I just say start the quiz, and boom, there's some text on the screen. So basically that's how it works. Now that this was just for testing. Now what we want is we want to start the quiz, right? So we're gonna see that in the next session, but what we can do right now is we can make some draw objects, uh, some functions basically that define. We just have like 10 minutes left. We can just make one function real quick, and then we can just say boom. Okay, so now as you can see in maybe this game, do we see this game, or do we see, okay, this is the game. Now if you see when we run the game just like so, there are four options available, and they are at the same position every time. Now they may change if the image is maybe now visible. Now here you can see they are changing. Now of course we're not gonna write draw the text of this function again and again four times for every time you just show a question. So basically we're gonna make a function for that same thing. So basically what is gonna happen is we're gonna say this function as draw underscore it underscore all. Now this is just the name of the function. Now here right now I can just say pass. Okay, so inside of this we can say we've got some different values, that is o1 o2 o3 o4 x1 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 y1. Okay, o1, okay, I'll just tell you what these are: o1 o2 o3 and o4, x1 x2, okay, x1 maybe y1, x2 maybe y2, x3 maybe y3, and x4 maybe y4. Oh, why did I give it? O1, O2, O3, O4, X1, Y1, X2, Y2, so 3. Okay. Now, okay. So we're gonna work with all these values, of course. Now we can just say O equal to, this is a function variable. It is in, okay. Of course, the options that are shown on the screen, they are of course text. So let's say font dot font. Instead, we can say ob.ttf because I like the Orbitron font. That's my cursor. ob.pdf. Then we can just give the values as 30, that is the text size. Now after o we can say k. These are just the some letters of the variables for that I just didn't find. No, not pygin but o dot render. Now here is text, that is basically the text that is gonna come inside of this. Now instead of this text thing, what we can do is we can replace it with o1 that we requested while like we requested these in the parameters, right? We need all of these variables or all of these values to use this function. So basically it's o1. The visibility is true, of course. I don't know what if you make it false, it just is like, yeah. So 255 comma 0 comma 255, this is the color for pink or the color of the variables. Okay. Now screen dot blit, here we can just give it as op, not opv. What is opv? um what the heck? Okay, no problem. We can just say screen dot blit. Here we can say k comma, that is basically what we want to blit, and then we can say x1 and y1. Now these are the values that we requested while defining the function. Now this was one option. Let's make another, and another. Copy paste this. for four options. Replace O1 with O2, O x1 with x2, y1 with y2. So all of these things are used. O1 with O3, x1 with x3, and y1 with y3. Here we can say O1 with O4, x1 with x4, y1 with y4. The time up. Okay, we have some time remaining. So basically, this is what will show all the options on the screen. Now, instead of draw it all, okay, we can just give it as draw it all. So I just want to show you how does this look. So basically, what if I say draw it all? What is this? Okay, we need 16 values, or no, 12 values. Okay, so basically these 12 values, let's say one is 20. This is the options or the text that we want. Two, that is the second option, is 20. Just giving it just for like illustration purposes or something like that. Three is 30, and the fourth one is 40. Okay. Now the x and y values of these things are basically, now this is not the real thing. Okay, I'm just showing it to you. Don't just copy and just like, this is not the real code. I'm just showing you how the function works, what is happening behind that function, and what all is just like going on, right? So 200, 500, 200, 550. Okay, where, so the y axis remains the same. You can just write 200, 550. What is happening? Everything okay? Not draw text. I'm gonna give draw it all. Just name the function something like that. So 200, 500, 200, 550. 200 is the x1. These are all the x and y values. Don't worry about that. We'll see what is happening. And they 200, 500, 200, 550, 200, 600, 200, 650. Okay. And let's see what happens when we just draw these things. Boom, you can see the functions, right? Not the functions, the options on the screen. Okay, if we click the button, nothing happens. Maybe I just erased the code, right? Yes, I did erase the code. Okay, so basically instead of just putting on text like hundreds of times for each question, what I did was I just created a function which just takes all the values. It just blitz all four functions onto the screen. So basically that is how it works. That's all for today. We're going to continue this game for the next session, and congratulations, you just completed your first project. Now we just loaded all of these images and we'll use it further. These are the two functions that we have, or let's say we got to be using. And after this, what we're going to do is basically we're just going to see the question mechanics, how the question will work, what are the clicks, how can we take the keyboard inputs. We can just we know what is basically happening, but I'll just simplify that for you. And that's all for today. Thank you for watching. And let me just close off this thing. Boom, exit. Google Chrome, that's the exit thing, and boom is the thing so working. Okay, and boom, it's live. It's okay, so it's basically 1 hour and everything's fine. So let me just end this thing.